We will be presenting our senior design capstone project, the Rockwell Automation Autonomous Guided Vehicle. With the advent of the coronavirus, automating processes in a factory environment has become especially important for cleanliness purposes. In addition, a rising trend in the industry is that of the cobot, a robot that can work in the same environment as a human employee with no danger of any incident or harm. We will be presenting such a robot, an AGV that can automate processes in a factory while working alongside humans safely and efficiently.
Our project is sponsored by Rockwell Automation, as they are providing most of the crucial components for the project, as well as our advisor, Michael Shute, who is a representative from Rockwell Automation. Our team members for this project are Josh Haley, Andrew Miller, Austin Burritt, Grant Matwiejczyk, and Branden Labarowski. So what is an AGV and why are they necessary? An AGV is an automated guided vehicle. It is a small vehicle that is able to move product around an industrial environment. They are very important because they increase efficiency and safety within the environment. They are especially important nowadays with the challenges faced with COVID-19, as they allow for the replacement of human workers for automated machine workers.
With the explosion of online retail and other large distribution logistical challenges, improvements in automation and efficiency have become critical in keeping up with market demand. Reducing cost and human error while increasing employee safety and operational efficiency has created an enormous opportunity for industrial automation. Currently, the distribution process requires trained and certified employees in high-risk environments. This training is not only expensive up front, but is also expensive to maintain. The inclusion of AGVs in production workflows improves operational efficiency, reduces risk, and increases the adaptive control of the supply chain management process as a whole. So why are AGVs the right choice? AGVs are important labor-saving devices for manufacturing systems. Machines that can handle simple and repetitive tasks lower the end cost of consumer goods by dramatically decreasing investment costs needed to move, store, and ship products at scale. AGVs are capable of transporting loads that could not be expected of by a person, and they save the need to certify an abundance of workers to operate heavy machinery. While vehicles can obviously outperform human labor, they can also operate in highly space-optimized environments that pose certain risks to employees and human-driven equipment like forklifts and pallet jacks.
The table currently visible lays out the project requirements that we intend to complete with this automated guided vehicle. The robot will be able to pick up, place, and carry the designated objects to their given locations. Constraints on our project include the fact that this will require zero human intervention as an automated vehicle. This diagram is the objective tree for our Rockwell Automation Automated Guided Vehicle. We intend to produce a safe and inexpensive vehicle which will be able to sense objects in front of it by detecting distance and color to dodge any obstacles that may be along its path. It will be able to pick up, place, and carry objects to their locations, and will use wireless communication to communicate with the power dock.
This is our functional diagram for the AGV, where we lay out how all the components of the AGV communicate with each other. We have error and fault monitoring and firmware updates that are applied from the power dock that gets connected to the AGV. It also communicates wirelessly with the Micro 850 controller during operation. The controller controls the lift mechanism and the drivetrain motors, and it communicates via UART with an Arduino that governs all of the sensors and scanners to provide information to the AGV so that it can detect objects and accomplish its job. On the left is our budget, which outlines the monetary upper limit of what we're going to spend on all the components that are going to go into the AGV. And on the right, we have our effort impact matrix, which outlines how much effort we need to spend on each of our objectives and how much impact we're getting from that to find the most valuable places to spend our time.
The automated guided vehicle will be able to navigate a grid pattern made out of magnetic tape on the factory floor. Two sensors at the front of the AGV will detect the tape, allowing the vehicle to travel along a straight line and not veer off path as it moves forward. Along the way, additional sensors on the side of the vehicle will detect perpendicular lines of magnetic tape that it encounters while navigating the grid pattern, In this way, the device will be able to keep track of its location and know when to make turns. When the AGV encounters an object that needs to be moved, it will identify it by scanning a barcode and matching it to the coordinates of its destination. Then, the AGV will use a lift mechanism to attach the object and carry it to its destination. At the end of workflow, when all objects are delivered, the AGV will navigate back to its charging dock. Throughout this entire process, the device is programmed to stop if it encounters an obstacle, such as a human employee. The following is a demonstration of our working prototype at the time of creation of this video. Although the lift mechanism has yet to be constructed, the proper functionality of the sensors and the ability to follow the magnetic tape can be observed. Please enjoy the demonstration.